Example 4 continues building off of example 3. It asks you to graph the ordered pairs and then analyze the graph. So remember, we've come up with all of the ordered pairs from our input-output table up here, and they've listed them here for you. 1, 7, 2, 14, 3, 21, 4, 28. And those all came from this function table, how many cars were washed, and then the total earned. So your cars washed is your your independent variable. Okay, that's what changes on its own, doesn't depend on anything else, it's independent. So that's going to be on your x-axis. And then the total earned depends on the amount of cars washed, so that's going to be on your y-axis here. So you'll need to label your axes like such, and then go ahead and graph those points just like you would on a regular XY coordinate plane. So you can see that they've already plotted the points here for you. What they haven't done is one thing we mentioned up in the key concept box is you need to take those points then and connect them, continue the line past it to show that it would continue if the amount of cars washed continued, and draw an arrow. So go ahead and do that now. And it should look similar to that, although maybe a little bit neater. And then the important part here is that it asks you to analyze the graph. So basically, what's happening here? What's this function showing us? So that's right here, that the graph is linear or creates a line, that's what linear means, because the amount earned increases by $7 for each car washed. So it's increasing at the same amount each time. It's not increasing by $7 and then increasing by 12 and then by 27 and then all these random amounts. So it's always increasing by the same amount. Go ahead and try the got it problems on the next page to check your understanding.